Hi and welcome. My name is Samir Maisekar and I'm the DevRel engineer here at SquareUp. Today we are talking about something that everyone is talking about. So that is how to observe your AI systems to stay in control of the cost, performance, and adoption amongst users. Now, bit of a fair warning, this will be a bit of a hand wavy session with not a lot of demos, unfortunately. But wait, don't tune out just yet. I promise it will not be too boring. Um, Hopefully not. So let's continue. All right, so let me quickly walk you through what we'll be covering today. Now, first, we'll start with why AI observability is such a big deal right now. Now, especially as AI adoption is accelerating across so many Microsoft technologies. Now, I will share some real-world reasons why keeping an eye out on your AI system is critical for both cost as well as user trust. So next, we will get into some core AI concepts. Nothing too fancy, just enough so everyone's on the same page, whether you are deep in the AI woods already or just getting started. Now, after that, we'll talk about the tricky balance between innovation and AI and cost of running AI systems. Now, AI can be powerful and it is indeed powerful, but it can also get pretty expensive pretty quickly. So you have to be extra careful. So I'll share some strategies to keep things under control. Then we'll look at how to actually measure AI performance. Now, it's not just about whether your models work, but how well they are working and how you can actually spot issues before they become problems. And finally, we'll wrap up with tracking AI adoption. So how to know if your teams are actually really using these tools and what you can do to drive better adoption across your organization. Now, do keep in mind that while this will be generally more targeted towards Microsoft AI, like for things like Copilot and Azure AI, um, a lot of this, if not all of this, also applies to any other AI systems in general. And so with that, let's dive in. Let's start by talking about why AI observability is so important right now. Now we are seeing AI adoption rapidly increasing, just accelerating, especially across Microsoft technologies. Just to give you an idea, the cost of using AI models has dropped dramatically. Right, so take GPT 3.5, for example, the query cost has fallen by more than 99% since 2022. That is a mind-blowing number, right? So, and that's made it much easier for teams to experiment and scale up their AI usage. But with that growth comes some real risk if you don't have proper observability in place. Now, you can end up with runaway costs, poor user experiences, or even a lack of trust in the outcomes of your AI systems. Now, basically, if you're not watching closely, things can get out of hand pretty quickly. Now, on the flip side, good observability lets you track your ROI, monitor performance proactively, and ensure that you're following responsible AI governance practices. Now, it's not just about saving money, it is also about making sure that your AI is performing as expected. And all of this isn't actually just theory. We are seeing observability become critical in products like M365 Copilots or Windows Copilot, GitHub Copilot, all the other Copilots out there, and more, right? So any systems that are based on AI or LLMs in the back. Now, as these tools become part of everyday workflows, which they are starting to be, staying in control of the cost, performance, and adoption is more important than ever. Now, let's take a moment to cover some of the core concepts in AI that are important for understanding how these systems work in general and how we can observe them effectively. Right? So, first up, we've got LLMs, the large language models. I think this everybody knows about these. These are the backbone of the most modern AI applications, and they power everything from chatbots to document summarizations, right? And they are trained on massive amounts of data and can generate human-like text. Now let's talk about tokens next. Tokens are the basic units of text that the AI model processes. Now think of them as words or pieces of words that AI understands. Every time you send a prompt to an AI, it's broken down into tokens, and the model generates output tokens in response. Tracking input, output, and cache tokens is a key for understanding usage and managing costs. We'll talk a bit more about these later. Next up, the context window is another important concept. This actually refers to how much information, or technically speaking, how many tokens the model can consider or process at once. Now, if your prompt is too long, or if you're working with a lot of data, with a lot of dimensions, then you might hit the context window limit, which can affect the quality of responses dramatically. Now, in the last and the recent past, the context window has grown up considerably. So from the days of, I don't know, 2019, 2020, coming up to 2024, 5, 6, the context window just keeps on going up. Hallucinations are when the AI generates information that sounds possible and sounds plausible, but it actually is not. Now, this is also a well-known challenge and has existed since the inception of LLMs, basically. Now, we do understand this challenge and we do acknowledge this challenge. And again, these have gone down considerably in the recent past, but it still remains a challenge, but hopefully not for long. Prompt engineering is all about crafting your inputs to get the best possible results from the model. Each model responds differently to the same prompt that you've given. You might have noticed that, right? So every model has, let's say, quote unquote, a personality, and you have to ask it questions, in the language that it understands the best. So that is engineering your prompt. So not only in the case of chatbots, but also this is especially more useful when you've got automations in place, where you've got LLMs feeding into one another, or LLMs feeding into others, non-Gen AI systems as well. So you have to make sure that you optimize the prompt to the best of its capability. And then finally, we've got fine tuning. So this is basically the process of taking a base model and training it further on your own data. And just to make it more specialized for your own personalized needs, right? So sometimes using a base model is enough. But in other cases, you have to go a bit further. And you may have to go for a RAG, retrieval augmented generation. So this is basically a bit advanced technique where your source of truth is external and your LLM system is actually referring to that source of truth, getting it into the system, into the LLM, and then processing it to create output. And then you've got fine tuning where you're actually changing the behavior of the LLM itself. Now, understanding these concepts helps us make informed decisions about how we can use AI, how we can monitor it, and how we can keep the costs and the risks to a minimum. Now let's talk about the trickier parts of working with AI, that is balancing innovation with cost, right? So as Oprah says, everybody gets a new copilot. You get a new copilot. You get a copilot. You get a copilot, right? So everybody wants a copilot. Everybody is getting a copilot. And it feels like every day there's a new copilot, M365, GitHub, security, Windows, Azure, just name it and you have it. The temptation is, of course, to use AI everywhere, but the reality is that the best way to save cost on AI is to not use AI at all. And as funny as it sounds, it's actually true. Because we have seen a lot of cases in the market where AI adoption is kind of getting out of hand, like in it's being applied or integrated with the services or in the use cases that do not require AI at all. A simple automation or a simple app with the regular logic baked into it can actually work just fine. But just for the sake of getting that AI label, a lot of applications, tools, and services nowadays are integrating with AI. So if your app does not need AI at all, try to avoid using it, or at least use it a bit wisely. A big part of cost control is also monitoring and managing your licenses, right? So for example, keeping track of who actually needs an M365 or GitHub Copilot license. Right? So, and making sure that you're not paying for seats that are not being used. Uh, if you attended the M365 session that I gave earlier, that you must have seen a dashboard where I showed an exact dashboard to track these things, right? To track the license usage, where you have a separate dashboard for Copilot even to track which users have been assigned this license and which users are actively using it, what was the last activity date, and across which services and so on. Now, LLM selection is the next. That is another area where you can make huge difference. Choosing the right language model is actually just not about performance, but it can have a big impact on your cost. Actually, sometimes a smaller, older, or more specialized model can actually do the job just as well or even better, and at the fraction of the cost. And I personally, I found this out the hard way when I was using LLM. Obviously, I wanted to use the greatest and the latest ChatGPT 5. But then I soon noticed on the dashboard that my costs were going exponentially up while my usage were more or less the same. That is when I understood or realized is I've got a problem here, right? So I reevaluated which model that I'm using. I quote unquote downgraded to GPT 3.5 Turbo, but I actually noticed that 3.5 Turbo was giving me better results with a larger context window and quicker response times than GPT-5. And so you, as I like to say, that you don't need a whole truck to transport a single pen. And so GPT-5 was way too powerful, way too versatile for my simple use case or a singular use case. And I didn't need to use it at all. So I ended up switching to 3.5, and I was only happier. Right? My cost went order of magnitudes down while my usage were increasing. Right. So again, like I said, choosing the right model is actually more important than you might think. Billing options matter also. So for heavy use cases, especially, switching from the classic pay-as-you-go model to pre-committed billing model like PTU-based billing can lead to advanced, significant savings. This is in the context of Microsoft AI Studio or AI services in general. But I'm sure other clouds or other LLMs also have a similar billing model to them as well. And now then there's the question of fine tuning, right? Sometimes the base model is good enough, like I said. Other times you might need to use techniques like RAG, um, or go all in on fine tuning, even if RAG is still not sufficient to your use case, then you can go just all in on fine tuning. Now, the key is to evaluate what actually delivers value for your use case, right? And then finally, don't forget to visualize your costs, right? Having dashboards that show you AI spend in real time makes it much easier to spot trends, catch anomalies, and stay in control at the right time, right? Like I gave you an example that is not an imagine, imagine the scenario at all. That is actually something that had happened with me. Thanks to the dashboard, I was able to quickly understand or notice that my costs were going up while my performance was more or less the same. And I was able to take quick actions based on that. So visualize, visualize, visualize. Now let's move on to how we measure the performance of our AI systems, right? So there are a few key things that to keep in mind here. First, we want to look at accuracy and relevancy. Now, this seems like a no-brainer. This seems like almost like a joke, right? So, but actually, as we discussed earlier, hallucinations are still very much a thing, and we have to constantly monitor whether if it's drifting from the expected output. This is actually fundamental because even the fastest or most sophisticated models is not of much use if it's not giving you the right answers. Response times are another big one. Users expect quick results, so monitoring latency helps us ensure a smooth experience, right? If things start to slow down, it's a sign that we need to dig deeper and optimize. Maybe we need to optimize our prompts. Maybe we need to change our LLM model. We need to probably do app distribution, things like that, right? Again, like I said, any principles that work for designing a good app in general also work for designing a good AI app, right? So all those principles still apply. Ethical use is also critical, while it may not seem as important, but it is actually we have to make sure that our AI system is being used responsibly and that it is not generating harmful or biased outputs. So this is where the human in the loop comes in. Now it's important to listen to what people are saying about their experiences and use that as a guide to improvement. So for that, um, you have to actually collect the user telemetry and make sure that your users are contributing to the improvement or the enhancement of your AI system as well. Now, when it comes to metrics, there are several that we should be tracking, like active users, how many people are actually using the AI system that you've designed, requests, the volume of queries or tasks being processed, and are these requests are they being distributed equally to multiple AI models or multiple AI systems? Latency, how fast the system responds. So after you type an input, how long does it take for the system to give you an output? Process tokens, again, this is the sum of input tokens and output tokens plus the cache tokens. Now, this will help us understand usage patterns and manage cost because, again, the more tokens that you process, the higher bill that you're going to get. And cache tokens are actually very important because every time an AI gives you a response, it caches some tokens. And if the next response contains tokens that are from the cached quota, they are actually discounted. So depending on the model, it is actually 50% or even 100% discounted in some cases. So that tremendously helps keeping your cost down. And then custom telemetry, setting up custom tracking for things that matter most for your organization, right? So there are things that are being collected out of the box, especially if you are using services in Azure. Then there are platform metrics that are automatically being collected by Azure itself. Then you've also got diagnostic settings that you can set up on top of the platform ones, and you can store it in Log Analytic Workspace for further processing and dashboarding. But in some cases, there are some metrics that are very personal to your application or to your organization that you have to make sure that you are baking them in, instrumenting the code for the app itself while you are deploying it. Right? So this custom telemetry will go a long way, and you will thank your past self for instrumenting this code. We also have, especially if you're hosting your services in Azure, then we also got supporting services in Azure, like Azure Monitor, like I just said. You've got Log Analytic Workspaces, or you've got App Insights, you've got Power Platform, you've got API gateways, you've got key vaults, storage accounts, databases, right? So all of your application will obviously need these components as well. So you have to make sure that you're using them, you're integrating your systems, you're monitoring your app as a whole, not only the LLM components, but also the whole application. So you get the whole context. Now, ultimately, measuring performance is not just about numbers, right? So it's about making sure that our AI is delivering the real value that it is designed for. It is staying reliable and that it's continuously getting better. How do you do that? Visualize again, right? So display key metrics for quick consumption and quick sharing. So you are always on the top of how many tokens are being used, are requests, there are failed requests, too many coming in the last, period. So maybe there is some anomaly going on in actual, maybe in the LLM itself or the non-LLM part of your apps. And so you have to, again, like I said, contextualize the whole application on a single dashboard and make sure that you've got all the metrics, all the key components at hand. Then let's wrap this up by looking at how we track AI adoption across our organization, right? First, we start with basic user activity metrics. This means keeping tabs on how many users have AI features enabled. So like the number of M365 licenses allotted and how many are actually active, whether that's daily, monthly active users, and so on. Again, in one of the other previous sessions, or one of the other sessions, the M365 session, there is a dashboard that I showed you that does exactly that. For M365 Copilot, it measures how many licenses have been allotted to which users, and what was the last activity performed by that user, how many are actually being used, and which ones are not. Right. It's also useful to look at the last activity date, like I said, so we can spot users who might be dropping off or need a nudge to re-engage, right? So you can nudge them to, hey, you've got a Copilot license, use it, right? So driving adoption. Trends are also important. By visualizing changes in adoption over time, we can see if the usage is growing, just stagnating, or just declining, and adjust our strategies accordingly. One of the most insightful metrics is feature usage. With custom telemetry that we talked about earlier, we can actually log which features are being used the most, especially if you're using your own custom app, and which ones are being used the most, and on the flip side, which ones are not being used at all. So this will help us understand what's driving more value and where we might need to invest in training or improvements and such. Well, and it's not just about usage for the sake of usage. We want to connect these adoption metrics to actual real business outcomes like cost savings or hours saved, productivity gains, things like that. So, for example, M365 Copilot will definitely boost your productivity, reduce the time it takes for you to complete a particular task, and so on. So you have to somehow log um, these savings as well, and then correlated with more technical things, the more technical metrics, so that you can prove with data that AI adoption, while AI adoption is increasing, productivity increases proportionately. And finally, visualization is key, right? Again, by graphing these metrics, we can quickly identify patterns, trends, and just making it easier to communicate results and to make decisions, right? So it's not only about counting users, how many users are using AI, but it is also about understanding how, why, and AI, how, why, and where AI is making a difference. Sadly, I don't have an active dashboard to show you, but I do have something to share. Now, these are the screenshots from the prototype of a new OpenAI plugin that I've been working on. It is still in progress, but as you can see, we've made real good stuff with it already. It contains the most useful metrics like the cost, total requests per day, cost per day, and some performance metrics like token usage and so on. So this is actually covering all the three sections that we just talked about. It is covering cost per day, total cost. It is covering performance, token usage, and it is also contains um, adoption, how many requests are being made and requests per day. And so this is a great way, like Inaika was showing earlier, visualize. This is where the dashboards actually play a crucial role to keep you informed on all three aspects of your application. Well, thank you. I hope it was useful. Thank you for joining me.